Hello everyone and welcome to the last part of lecture 4. Today we have the problems we want to solve and we want to find the power and the work done of the heart. The work done is pressure multiplied by delta V, and P is the pressure, delta V is the volume. Pressure, as you know, that the pressure coming from rho GH, and rho is the density, G is the gravitational acceleration, and H is the height or pressure in millimeter of mercury. If we are this is for the work done. The P is power. Okay, the power is the work done, number of beats time over time, and is measured by watt. So you know that the work done is what? The work done is P delta V, and P is rho GH. Combine them together, W will be equal rho GH delta V. So rho GH delta V times number of beats over time in second. Okay, and rho GH in this case rho GH should be always have a meter. So at the end you will have joule per second. You will give you what? You will solve the problem and you will see what I'm meaning. Delta V is the meter cubic, should be always. So sometimes delta V given by centimeter cubic, milliliter, and liter. You should transfer them to the what? To the millimeter cubic. 1 centimeter cubic equal 1 milliliter, and it's equal 10 to power minus 6 meter cubic. 1 liter is equal 10 to power minus 3 meter cubic. We will solve the problems and you'll see how it works together. The first example we have it is just like a person has a systolic pressure 150 millimeter mercury, and the diastolic pressure 100 millimeter mercury. Heart rate 90. Calculate the work done and the efficiency of the lower left half of the heart if the energy consumed is 6 joules. So now first of all I want the work done. You know that the work is equal P delta V. P is the pressure coming, because I don't have pressure, I have the H, so it's coming from rho GH. Now H, we have systolic and diastolic pressure. To find H, I think I didn't mention here, H is coming from H average, which is H systolic plus H systolic plus H diastolic over 2. So then H average, which H systolic plus H diastolic over 2. Now I will do it. H average will be H systolic is 150 plus H diastolic is 100 over 2. It will be equal 250 over 2 is equal 125 millimeter mercury. H. So do it in meter. H average is equal 0.125 meter mercury divided by 1000. Now apply there, because it's mercury, so I will say P equal rho is 13.6 times 10 to power 3, 9.81 multiplied by H 0.125. If you multiply together, you will get 1. It will be get 1667.70 Newton per meter square. Then I will put this P, then I will find delta V. Delta V is the volume, and the volume is coming from amount of blood for each beat per minute, or per second, sorry, multiplied by number of beats. Now the amount of, if he want amount of blood and he didn't give it to you, is constant, is equal 80 milliliter second over beat. multiply by what? Multiply by how many beats we have? 90 beats per minute. And because I have minutes and seconds, so I should transfer them. So I will multiply by 1 minute over 60 seconds. So it can be minute go with the minute, second with the go with second, and beat with the beat. You will have just the milliliter. So the answer will be 120 milliliter. Alright, and then transfer this one, delta V will be equal 120 multiplied by 10 to the power 6 liter. Now I have delta V, I have V, I will apply the answer to get the, so the work done will be equal P delta V, it will equal 1667.70 multiplied by 120 10 to the power minus 6. The answer will be 1.995 so joule, because the unit of the work is joule, which is the same as joule is the same as a Newton time meter. Okay, now this is the work done. Now what he wants else? He wants the energy consumed. If the energy is 6 joule, efficiency. The efficiency, how can we find it? Efficiency will be the work done over energy consumed multiplied by 100%. So work done is 1.995 over 6 multiplied by 100%. It will be 33.25%. This is the first one. Again, quickly, he wants the work done and the energy consumed. The work done is P delta V. P is rho GH. From P, I have rho, I have GH is H average coming from H systolic plus H diastolic over 2. Find the H average, apply P, then delta V. You will find the work and then you will find the efficiency. The second example we have it is the work done. Let me show it for you here. The work done by the is 1 joule. So he give you the work is 1 joule per beat. Okay. When he said per beat, that means you will expect he have number of beats. Again, when he said per beat, that means you will expect what? You will expect he give you number of beats. So work is 1 joule, number of beats is given as well. Calculate the power of the heart if the beat is 72 beat per minute. Okay, I know the power is delta is W time number of beats over time in second. To be careful, time should be what? In second. We have here what? Minutes. So should transfer it. P will be equal. The work done is 1 multiplied by number of feet 72 over time in second. This is minutes. 1 minute it will be 60 seconds. The answer will be 1.2 watt. Alright, simple, straightforward. Now, the second example that we have is just the heart take and discharge 7,500 liters of blood in a day. So he didn't mention beat. So that means there is no number of beats. Okay, so our number of beats will be equal 1. Density of the blood is 1.505 times 10 to the power 3 kilogram per meter cubic. And if on average it take to the height of 1.6 meter. So this is rho. This is H. And he wants what the power of the heart. The power of the heart is W times number of beats over time in second. Okay, this is a day, so this is the time. Okay, I don't have the work, but I know that the work is rho g h delta v multiplied by number of beats over time in second. Okay, rho is given 1.05 times 10 to the power 3. G is 9.81, should be all of them in meter. All of them should be in meter. It should be meter. There is no other choice. All of them should be meter. Multiplied by H is in meter already, 1.6. Multiplied by delta V in letter. And here I mentioned, if he give you the delta V in letter, it will be multiplied by 10 to the power minus 3 to transfer to the meter cubic. So that means it will be 7,500 multiplied by 10 to the power minus 3 over time in a day. I should transfer to the what? To the second. So time is day. The day is 24 hours. The hour is 60 minutes. And the minute is 60 seconds. All right. Now this one in meter, this one in meter, this one in meter, this one in meter cubic, and this one is second. It will be get you the watt that you want. And the answer, if you are multiplying it together, it will be 1.43 watt. And this is the end of the second one. The third one, the human heart discharges 75 milliliter of blood at each beat. When he said at each beat, that means I'm expecting to have what number of beats? Okay, 75 milliliter, that means delta V. Against a pressure of 0.1 meter mercury. This is H, and you know, calculate the power. You want P, the power of the heart, assuming that the pulse frequency is 80 beats, as I said, because he said each beat, that means I'm expecting what? To have number of beats per minute. Time is given in minutes. So now I will say power. I know that is rho g h delta v, number of beats over time in second. Now rho is 13 because it's mercury. That means 13.6 times 10 to the power 3. G is 9.81. H is 0.1 is given. Delta V is 75. Now it's milliliter. And as I explained here, again, I will show you 75 milliliter. When it's milliliter or centimeter cubic, you will multiply it by 10 to the power minus 6. So it will be multiplied by 10 to the power minus 6 over time in minutes. So I will transfer to the second. I will divide by second. The answer will be 1.33 watt. So the most important one is just like all of them should be have in meter and time should be in second. Because why? Because this is it will be give you what? Give you joule. This the new denominator. The denominator will give you the second. Joule over second is what? It will be watt. Okay? So W watt, and this is the watt here. And this is the end of this section. Thank you very much.